we are going to start looking at the last new information for section 1.1. So it's going to be the last new information before our quiz next Wednesday. And it's the last measure of spread. So up to now, we've talked about how to display quantitative distributions. So box plots, histograms, dot plots, stem plots. So we talked about how to graph them. We also talked about how to describe them. So shape, symmetric or skewed. Center, whether it's symmetric or skewed will determine whether we use mean or median. And then spread. Every time we say something about center, we also have to include spread. So far with spread, we've talked about range, max minus min, and we've talked about interquartile range, IQR, quartile 3 minus quartile 1. The last one we're going to talk about then is called the standard deviation. Now you guys have worked with standard deviation in previous classes, I'm pretty sure, at some point. Did you ever work on actually calculating it? Maybe not so much. Standard deviation, that's something you've seen before. Usually, they use it a lot in science classes, usually. If any of you guys are in psych, when you guys are doing, like a lot of the stuff we do here might match up with what we do, what you guys do in psych as well, so some of that stuff might come into play too. But we're going to talk about basically what the standard deviation is and then how to calculate it. Now we'll do it by hand, and I'll show you how to do it in the calculator. And so that way, once we get into it and they ask you to calculate a standard deviation, you can pick which way you want to go. Probably the calculator is going to be your best option, though. It'll be a lot quicker. So, first, let's talk about what standard deviation is. So standard deviation, for now, is going to be denoted with a lowercase s. So when you see a lowercase s, usually it'll be like italicized. That is going to denote standard deviation. So two notations we have so far. Mean. How do we denote mean? That x bar. So x with a bar over it. And then standard deviation has that lowercase s. So what standard deviation does is it measures the spread of the distribution by looking at how far the observations are from their mean. So what it does is once we have our mean, it looks at how far each individual observation is away from that mean. And then essentially gives us like an average distance from the mean. So it takes every single value and calculates how far away is it from the mean, and then uses that to kind of create an average distance from the mean. So we can kind of see from that mean point, that center, where are we spreading around it. Okay? It is used with mean. So since we need to figure out how far away the points are from the mean, it's used when we choose mean as our center. So yesterday we talked about with median, we always use what measure of spread? Range and IQR. So median and IQR pair together. Mean and standard deviation pair together. That's extremely important. If you choose mean as your measure of center, you have to report standard deviation as your measure of spread. So you cannot say mean and then give an IQR. They don't go together. Okay? So mean and standard deviation are going to go together. Same thing here. Standard deviation should only be used if mean was your center, which means only when your distribution is what? When do we use mean as our center for a distribution? When it's symmetric and no outliers, right? So if it's symmetric and no outliers, we're going to choose mean for our center, which means we're going to choose standard deviation for our spread. If there are outliers, if the data is skewed, we do not want to use standard deviation. Okay? Standard deviation, like mean, accounts for every single point in the set. So if there are large values way above normal or way below normal, that standard deviation is going to be thrown off by those values. Okay? So, like mean, it is not resistant. Remember, the term resistant means outliers and skewed data do not affect the value. That's not the case with mean and standard deviation. Those are both non-resistant measures. If there are outliers, if the distribution is skewed, those values will be greatly affected by those two things. So that's why we only choose those when we have a symmetric distribution with no outliers involved. Okay? Now, the reason we need to know about standard deviation, and this will come into play next chapter. So when we get to chapter 2, coming up next week, we're going to be talking about normal distributions. And in normal distributions, we use the standard deviation as a unit of measure. So like we would normally use inches or meters or yards for units of length and things like that, or units of measure, we use standard deviation for units of measure with normal distribution. So it's important to know where it comes from, how to calculate it, what it really means. Okay? All right. When we calculate standard deviation, just like any other measure of spread or any other measure of center, they always have the same unit. So if you have units of pounds in your data, standard deviation is going to be in pounds. If it's inches, it's going to be in inches, and so on. So units of measure are always the same with standard deviation in the data. So to calculate standard deviation, now this stuff you don't necessarily have to write down a lot of. Okay, we're not going to deal with variance in most cases. Like we'll talk about variance when we get into some of the later chapters and we're talking about random variables. Variance will be kind of an important issue, but for right now it doesn't mean much to us. So variance is denoted as S squared. So it's the standard deviation squared. So if we want to calculate our standard deviation, we need to find the variance and find the square root. Now, to calculate by hand, this is the formula to find variance, which means if we want to find standard deviation, we need to take all of this and take the square root of it. Okay? Now, it looks like a very complicated formula, just on the first look. But if you kind of notice, there are some things, and we're going to talk about a word process that makes it kind of easier to keep track of what we're doing. But for the most part, what are some things you recognize in that formula? The mean. And notice in every set of parentheses, what is there? The mean, right? Every set of parentheses, every single thing is subtracting the mean. So what this little x1, x2, xn is talking about, we're taking the first data point and subtract the mean from it. Take the second data point, subtract the mean. Take the third and fourth, and then however many we have, every point gets subtracted from the mean, or the mean gets subtracted from it. Okay? Once we find that, we are actually going to square each individual difference. So once we've calculated the differences between the value and the mean for every single point, then we square all of those differences. Once we've squared all the differences, we're going to add them all together, and then we're going to divide by the number of observations minus 1. Okay? So some things to remember. X bar is just the mean. That's consistent with every single piece up in the formula there. And then n is just the number of observations. Now some terminology. On the top here, these little x minus x bar squared, those are the squared deviations. Deviations are the difference between a point and its mean. So when we say kind of standard deviation, we've calculated the deviations for every single point in the set, and then we're going to look at kind of the average of those deviations. That's what this process is kind of going about. The other thing, and this again will come into play much more later on, some of the later chapters, but that n minus 1 on the bottom is what's called our degrees of freedom. So if you see the term degrees of freedom, for standard deviation, that just means you take the number of observations minus 1. So the process boils down to finding the deviations, squaring those deviations, adding them all together, divide by degrees of freedom, and then we just take the square root of the entire thing. So everything we found goes into the square root. Okay, so we're going to do this example. We're going to do it by hand, and then we're going to do it in the calculator so you can kind of see both methods. Okay, so if I want to find the standard deviation by hand here, the first step is to find the mean. Okay, so the first thing we have to do is find the mean of our distribution. So, if we wanted to find the mean, we have two methods of doing that. Either add up all the values and divide by n, or you can plug it in your calculator, do the 1-bar stats, and get your mean from that. Okay? So let's go ahead and do that method. So plug it in your calculator, so get the values entered into your calculator, go into list 1, and calculate the mean for the distribution. Now when you calculate mean, leave that screen up on your calculator. Don't touch anything after you get the mean up on your calculator screen. Everybody got the mean? What do we have for the mean? 29? Okay. So, calculating means first step. We need to know what the mean is so that we can find the deviations, square them, add them together, divide by degrees of freedom, take the square root. Okay? Now, while you're on that screen, if you look down the list, you should see an SX on the screen. Does everybody see that SX? So SX is just saying that's the standard deviation for our x variable, the list 1. So what does the standard deviation on your screen say? 4.69. Okay. So when you calculate the mean, like if I ask you a question on the quiz or test or something like that, calculate standard deviation by hand. Okay. The first step you would do is calculate the mean. So if you did this process, you're going to get the mean. You're also going to have the standard deviation right there. This allows you to check that you did the process correctly. So on those types of problems, I'm not going to care that you got the right answer because the calculator is going to tell you that. I'm looking at the process. Do you know how to do it by hand? Okay? So this allows us to check. So when we go through our process here, we should be coming out with something close to 4.69.
So like on the test and stuff, will it only be like 5 numbers?
Yes. If I ever have you do it by hand, this will be the most. Like you might have 4 or 5 to work with. So yeah, we're not going to worry about big sets. If it's a big set, you will do it in the calculator every time. Okay? So we know the mean. We know what our standard deviation is supposed to come out to be. Now, the process, if we try to plug it into the formula, some of you guys like just, hey, there's my formula, I'm just going to plug it in every time and work it out that way. The other way, the way I do it, is I kind of create like a 3-column table. Okay? So my first table, or first column, I'm just going to calculate my deviations. I'm just going to take each x value minus the mean. And in my second column, I'm going to take those differences and square them. Okay? So if we follow this, and we'll talk about the third column here when we get to that point. So if we follow this, I'm just going to take every x value minus the mean. So I just go down the list. So I'm going to take 23 minus 29. And I get -6. Then I'm going to take 35 minus 29. +6. Take 34 minus 29. Okay, 27 minus 29. Negative 2. Okay, 29 minus 29. 0. And then 26 minus 29. Okay. So the first step, just find those deviations. How far away from the mean is every point, and in what direction? So we do want the negatives in there, because that tells us it's below the mean, or a positive tells us it's above the mean. Okay. So once I have my deviations, my second column is where I want to square them. So negative 6 squared is 36. 6 squared is 36. 25, 4, 0, 9. Okay. So now we've taken our deviations, we've squared them. What do I need to do with these squared deviations? What did the formula say? Add them all up. So at the bottom of the column here, I want to add up all of these squared deviations. So what do we get if we add up all those values? 110. Did I get 110? Okay. So there's the sum of our squared deviations. That's the entire top of that formula. Done right there. So 110 would be the sum for that top part of the formula. So then when I come over here, this is where I just say I'm calculating x. So here's where I'm actually going to calculate my standard deviation. So to calculate standard deviation, we said we need to take that top total, the sum of the squared deviations, the 110, divided by, what was on the bottom? The number of observations minus 1, those degrees of freedom. So how many observations do I have? 6 minus 1 would give me 5. Now, this alone gives me variance. So once I take the 110 divided by 5, what else do I need to do to it? Square root. Okay? So in your calculators, you take 110 divided by 5, and then take the square root of that value. You should get 4.69, which we know should be good because our calculator told us the same answer. Okay? So on a quiz or test, if I ask you to do it by hand, I think there might be one question like that. Okay? It'll only be like 4 or 5 values, so it's not going to be something that's going to take a long time to do. I either need to see this process, so if you'd like to organize in a table manner, or the formula. So if you want to memorize the formula and plug it in like that, you can do that. Okay? But I need to see the work. I can't just get standard deviation because I know you can get that in the calculator just by plugging in the values. So if it says by hand, I want you to do it by hand like this.
If we do it in like a formula method, do we like just plug in all the numbers, or do you want us to like step by step?
What do you mean?
Like,
oh, if you write out the formula?
Just like leave it long
no,
and then plug it into a calculator, or
yeah,
do
you can do that. If you write out the entire formula, I can see that you know how to plug it into the formula. You can plug that all in your calculator at once. You don't have to show, okay, after this, this is my next step, this is my next step. You can go straight to the answer from that. Yeah. Any questions on that? Okay. So last thing, just kind of a big overall review. When we describe distributions, which measure of center and spread do we have to choose? So when your data is strongly skewed, or when it has outliers, always use the 5-number summary. So calculate that 5-number summary, give the median, calculate the IQR. Just giving the quartiles isn't enough. You actually have to say the IQR is, and then what's the difference between the quartiles. So give the 5-number summary, and then physically report the median and the IQR. That's going to be your center and spread. If the data is symmetric, we want to use mean and standard deviation. Now notice the wording here. If the data is strongly skewed, use the 5-number summary. But if the data is reasonably symmetric, use mean and standard deviation. So if you have you're wavering between saying skewed or symmetric, if it's kind of a close call, you want to stick with mean and standard deviation. These are stronger measures because they account for every single value in the set. So we only use median and IQR, the 5-number summary. We'll only use that if it's strongly skewed. Anything else, we want to try to use the strongest possible value, and that's mean and standard deviation. Okay? That's it. That's the end of chapter 1. Okay? So, I want you to try these problems out. So 99 and 100, 103, 104, those are going to be like short answer questions. 107 to 110 are multiple choice questions. And then 111 is one that kind of puts everything together into one problem. It's a short answer, but it kind of puts everything from the chapter kind of together into one problem. Okay? So, the rest of the time is yours. So you need to use it to work on finishing up any assignments you haven't turned in yet. So if you still have missing assignments, get those finished and turned in. Otherwise, you can start working through this assignment. With 25 minutes, you should be able to get a pretty good chunk of it done. Maybe even possibly get it all done, and you don't have to worry about any homework over the weekend. Okay? Keep in mind, Monday when we come back, Monday will be what we call a homework day, so you will have time to work on homework. That will also be a time to ask questions. If you don't understand a specific concept or something that we've gone over so far, those are the days to ask those questions. Get those things figured out then. Tuesday will be a review day. Wednesday will be a quiz. Okay, so just be aware of what's coming up next week as far as planning.
Can I close up?